Hi, welcome to the next session in Signals and System. Today we are going to discuss about elementary signals. Who is elementary signals? They are the basic building blocks. They are the fundamental signals for any complicated signal. For example, for any building, brick, cement, iron rods are the elementary particles. Like how for a building we had bricks as a basic construction material, iron rod which is a construction material, cement is a construction material. For any signal, what is the construction material we are going to have? Which is nothing but unit step signal. Another is unit impulse signal. Another is unit ramp. Like this, we are having many. Is something like you should recall. It is something like a brick or a cement or iron rod or water or a sand, something like this. Number 4, sinusoidal. Number 5, exponential. Number 6, Signum function. So these are all the basic elementary signals, or we can say fundamental signals in our signals and system. Let us see definitions of all these signals and the problems in all these topics. Make a note of this. Let us see unit step signal. What is unit step signal? Its amplitude is 1 in the right side, going up to infinity, and in the left side the amplitude is u. We give the symbol as u. U stands for unit step signal, which is u of t. What is the u of t? The definition is u of t is, what is the amplitude? 1. Which side? Right side, for t greater than or equal to 0. What about for left side? For t lesser than 0, it is 0. Same you are having even in discrete also. That is u of n. Am I right? Here the amplitude is same 1, where in right side 0, 1, 2, 3 dot dot dot. What about in left side? 0. Concept is both are same. What is u of n, whose amplitude is 1, where for n greater than 0. Left side, what is the value? Who is 0 for n less than 0. This is the definition of unit step. Next is unit impulse. What is unit impulse? In fact, it is a pulse signal whose symbol is del of t. We say it is a pulse whose width is small. If the width become very minimum, then become impulse. The same in discrete also we are having. At 0 it is 1. This is del of n. This is del of t. What is the definition? Del of t is the symbol for the impulse signal. Its amplitude is 1. Is it everywhere? At one place. At one place. Where at t equal to 0. And it is 0 for t is not equal to 0. This side and this side. Same del of n is 1 for n is equal to 0 because it is discrete. And it is 0 this side and this side for n is not equal to 0. Who is impulse? It is a pulse signal whose width is very small. The third elementary signal is unit ramp. What is that unit ramp? This is the ramp signal up to infinity. I hope you Can you recall this? We say T, am I right? Yes, it's C. The amplitude is T. Where? In right side for T greater than 0. In left side it is 0. What is the symbol? R of T is the symbol. This is the right side. Same we are having in discrete also. At 0 it is 0, 1, 2, 3, 4, dot dot dot. In n. This is called R of n. So what is R of n? Here you have T. You are having n for n greater than 0 and it is 0 for n less than 0. This is your ramp signal. The fourth subdivision is sinusoidal. Just a sine wave or even a cos wave. It is called sinusoidal. So, who is the x of t is nothing but sine omega t. In case if there is a phase shift, it will be plus theta. Let us say what is the amplitude? A. So let me say A sine omega t. This is for continuous. Same even I can have for the discrete. Most of the people can't imagine what is a discrete sinusoid. This is your discrete sinusoid. Sine omega n. Sinusoid. The next classification is exponential. What is an exponential signal? This is your exponential signal. Same even I can have exponentially decaying. What about this? Exponentially growing. At 0 it is 1 because e power 0 is 1. So, who is this signal? It is e power minus at. A value can be anything. Who is e? E power at. It's all positive, exponentially growing, that is negative, e decay. But this both is for continuous. Do you have for discrete? Yes, of course it is there. But one of the wrong assumptions by most of us is e power at, it will be e power an. I'm sorry, it is not that. It is a power n. The same discrete signal in decaying is also x of n is equal to a power n. What is a power n signal decaying? Like this. What about growing? Like this. Sir, what is the next classification here? If a value is greater than 1, obviously it is growing. If a value is lesser than 1 and it is greater than 0, fraction, then it is decaying. One small recap. Can you assume one a value which is greater than 1? Yes, 2. So if I just substitute 2 power 0, 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, yes, it's growing. 2 power 0.5, that is minus 1, it's nothing but 0.5. Can I assume one a value which is lesser than 1? 0.5. So if we take 0.5 power 0, 1. 0.5 power 1, 0.5. It's going. 0.5 power minus 1. Please recall, 0.5 power minus 1 is nothing but 1 by 2 power minus 1 is nothing but 2. So this is called decaying, this is called growing. Make a note of that. The last subdivision is Signum function. What is Signum function? We won't use in our signals system. Broadly, it will be used in digital communication. Its amplitude is 1 in right side. It looks like unit step. And its amplitude is minus 1 in left side. So this is your x of t, signum of t. What is the amplitude? It is 1 for t greater than 0 and it is minus 1 for t less than 0. This is your signum function. Let us see some problems on these elementary signals. sketch the following signal: u of t minus u of t minus 3. Can you recall? What is u of t signal? It is unit step. Am I right? This is u of t. You should recall the old topic. What is u of t minus 3? Yes, you are right. It is right shift. Right shift by how many values? Good. 3 values. Instead of starting from 0, it starts from 3. Right? So, who is he? U of t minus 3. So, what is that I should do? This signal minus this signal. So, just I am going to subtract. If I subtract, what will be the result? Just directly let us calculate. Before 0, I hope there is no value. Am I right? 0 minus 0, I am talking about amplitude. 0 minus 0, 0. So, 0 to 3 we will calculate. Then after 3 we will calculate. 0 to 3 how much? 1. 0 to 3 how much? 0. 1 minus 0. Answer is 1. Where? 0 to 3 it is 1. After 3, 1 here. 1. 1 minus 1. Answer is 0. After 3 how much it is? 0. This is the signal x of t. In the same way, we'll have some other signal which is u of t plus 1 minus 2u of t plus u of t minus 3. Don't get complicate yourself. Individually sketch these 3. Do these calculations. Come on. What is first signal? U of t plus 1. Good. It is left shift. By how many value? 1. That's all. This is u of t plus 1. What about next signal? U of t. What is your u of t? It's like this. But careful. Its amplitude is 1. But right now, what is the amplitude? 2. Sir, this minus that you will see later. Right now, I have plotted 2u of t, whose amplitude is 2. What is the third signal? U of t minus 3. Right shift or left shift? Come on, right shift. Right shift by how many value? 3 value. You recall your basic signal 0 to. Recall your u of t signal. Am I right? Right shift by 3 value. So it goes to 3. Whose amplitude is 1. So right now I am ready with 3 different signals. U of t plus 1 is here. 2u of t is here. Minus is not here. Okay. U of t minus 3 is here. Now what I should do? First signal minus second signal plus third signal. So what is the resultant signal? Is nothing but x of t. These locations you please indicate here. First signal minus second signal plus third signal. Okay. Before minus 1, 0. Minus 1 to 0, 1, 0, 0. As per this format, 1 minus 0 plus 0. Answer is 1. Next, I need 0 to 3. 1 minus 2 plus 0. 1 minus 2 plus 0. Answer is minus 1. Wherever 0 to 3, it is minus 1. After 3, come on. After 3, 1, 2, 1. What is that calculation? 1 minus 2 plus 1. Answer is 0. This is the final signal. Make a note of this. Let us see. Next problem. X of n is equal to 3 minus n into u of n plus 1 minus u of n minus 1. Can we do this? Yes. You do this, then you modify the amplitude as 3 minus 1. Okay, first let us target on this particular signal. Okay, time being, don't see this. What is u of n plus 1, which is left shift? Am I right? Whose amplitude is 1. What is u of n minus 1, which is right shift? Right shift, whose amplitude is 1. Starting from, am I right? So 0, 1, 2, 3, 4. This is signal is ready. We made a discrete because given problem is discrete. U of n minus 1. Be careful. U of n plus 1 is here. U of n minus 1 is here. Left shift, this is right shift. What I should do? I should subtract these two signals. Now what is the subtraction? U of n plus 1 minus u of n minus 1. Okay, let us start it out. Just individually calculate. Anything before minus 1, 0. Am I right? So 0 minus 1, 0. At minus 1, try to tell me. At minus 1, how much? 1. At minus 1, how much? 0. What I should do? Subtraction. 1 minus 0, 1. Where? At minus 1. At 0, how much? 1. At 0, how much? 0. 1 minus 0, 1. At 1, how much? 1. At here, 1, how much? 1. 1 minus 1, 0. Generalize. After 1, everywhere amplitude is 1. Everywhere amplitude is 1. Subtraction. 1 minus 1, 0. Who is this signal? It is u of n plus 1 minus u of n minus 1. But do you need this signal? No. What is it I need? U of n plus 1 minus u of n minus 1. Is it everywhere? No. It is only at two places. Where? Minus 1 and 0. That's all. First understood that. In this location, is it amplitude is 1? Yes. What is its amplitude? 1. Right now, what is the amplitude? 3 minus n is the amplitude. So, in n signal, that is, n is equal to 0. This is n is equal to minus 1. Come on, you just substitute. Put n is equal to 0. Where? Here. N is equal to 0. What is the amplitude now? 3 minus 0? 3. What is the location? Minus 1. Minus 1 or n is equal to minus 1? N is equal to minus 1. Substitute. Minus or minus plus. Answer 4. Why this side not there? Because signal is not there. So who is he? This is your x of n. Now this is the question. Sketch x of n. But in question what we used to ask, after getting this signal, can you sketch x of 2n minus 2? Can you recall what is this problem? Yes. Right shift by 2 value, compression by 2 for this particular problem. Okay. Right shift by 2 value, then compression by 2, that you can continue later. Okay. So this is the usual problem. Let us see another problem. I have given one signal x of t. Now the question is, sketch y of t, which is x of t, this signal, into u of t minus u of t minus 1. What is it I am asking you? Sketch y of t. Just simplify. Who is he? Given. Who is he? Plot. Let us plot. What is u of t signal? Let us plot. What is u of t signal? This is u of t. What is u of t minus 1 signal? Is it right shift? Yes. Who is e? U of t. Who is e? U of t minus 1. What I should do here? U of t minus u of t minus 1. If I subtract, what will be the result? U of t minus u of t minus 1. This side 0. 0 to 1, 1 here, 0 here. 1 minus 0, 1. This side 1 minus 1, 0. That's it. Who is e? U of t minus u of t minus 1. This signal is here. This signal is here. What I should do? Multiply. Just if you multiply, the result is y. Very simple logic. After 1, how much? 0. 0 into anything? 0. So, after 1, it is 0. Before 0, 0 amplitude. Some signal is there, but if you multiply, 0. So, before 0 also, it is 0. 0 into 5, 0. 0 into anything is 0. Between 0 to 1 is the issue. Between 0 to 1, how much? 1. Between 0 to 1, how much? 1. What I should do? Multiply. 1 into 1, 1. That's all. Thank you.